3 times 10 to the 8th meters per second. V is the speed of light in the medium we are looking at. So if we're looking at glass, V is the speed of light in glass. If we're looking at water, V is the speed of light in water, right? So you always know what C is because it's always 3 times 10 to the 8th. And they'll give you, say, a V, right? What the speed of light is in the medium you're looking for. And you could find the index of refraction, the N value for that medium, right? You can also see that there can never be an N value less than 1 because nothing can be, if you're looking at C over V, if you had an N value less than 1, that means V is higher than C. That means light is faster in actually that medium than it is in a vacuum, which is not possible. Light is always fastest in a vacuum. So you can never have an N value less than 1. So if you did a calculation and it's less than 1, you know you did something wrong and you should redo it. We consider air to be essentially a vacuum. So N is in air is also 1 since C and V are the same, right? That's about it. Just using N equals C over V and this equation, N1 sine theta 1 and equals N2 sine theta 2. You should be able to answer almost any refraction problem, okay? All right. Well, we mentioned the theta is with respect to the normal, but what happens if theta is actually greater than 90 degrees, right? Because the normal is a vertical line, and then the boundary, which is the area that separates air from water or from the two, whatever the two substances are, is perpendicular to it, right? It's like this, and you can see it right here. What happens if the theta is actually greater than 90 degrees? And you can see that right here. This is what we were just looking at, a normal line, just changes like that. This is what happens if it's 90 degrees. And what happened in this case is actually you wouldn't see it. So going back to the example of the pencil in water, put a pencil in a glass of water, you can see it, it's just crooked a little bit. If you have 90 degrees, you put the pencil in the water and you can see it about in the air. But as soon as it goes into the water, you can't see it anymore. All right, because none of the light is shining through. Okay, so it's 90 degrees. If you go above 90 degrees, say 110 degrees, you have something like this. And this is called total internal reflection, right? What it just means is that none of the light is able to refract. All of the light just gets reflected right back at you from the medium you're going to. Total internal reflection can only happen when you're going from a higher medium to a lower medium. So say water to air or glass to air. It can never happen when you're going from air to water. The reason for that is actually because when you're going from air to water, like I mentioned, from a lower index to a higher index, the angle actually has to decrease, right? So if you have an angle of 30, it would decrease. It can't increase past 90. Whereas where you're going from a higher index like water to air, the angle can actually always increase. So it goes from, say, 70 to 90 or from 80 to 95 or something like that. And that's when you get total internal reflection. It can only happen when you're going from a higher index substance to a lower index substance like water to air or glass to air or something like that. Right? And again, total internal reflection is when the angle, the theta 2, between the normal and the ray that's coming out, the resulting ray, is over 90 degrees. And what you get is actually something like this, where rather than coming out crooked, it actually doesn't come out at all and it reflects back, right? Say like this angle is, say, 120 degrees, right? And it doesn't come out of the, like it was going from the water into the air, it actually doesn't come out of the water and you can't see it when it comes out, it just goes back in, the light, and you wouldn't be able to see it in the air, okay? Essentially, the light gets trapped underwater. Next, I want to talk about reflection a little bit. This is very basic reflection. Apart from refraction, there's also reflection. Any surface can be and is reflective if it is also refractive. So refraction and reflection happen all like together all the time. If you even want to look back at this, You see, this is the classic example of refraction, right? Going from here to here. But you also notice this like light blue line right here. This is reflection, right? So this light ray is being refracted, but at the same time, the same light ray is also being reflected, right? They happen simultaneously, okay? And in the case of total reflection, there's actually no refraction, there's just reflection, right? But most of the time, when you have refraction, you also have reflection, right? Reflection is very easy to calculate for just a linear surface. So for example, like the boundary between air and water is a straight line, horizontal line. The angle of reflection is always the same as the angle of incidence, right? So you're coming in at θ1 this way. Reflection is exactly the same. You're going out like this. The angle is also θ1, just like this, right? Reflection, the angle coming out is always the same as the angle coming in, right? But you also have refraction, which has a θ2, which is a different theta. And the reason reflection is the same as coming out is the same as coming in, because you do n1 sine θ1 sine θ1 equals n1 sine θ2. What's θ1 and the θ2? Well, if n1 is the same here and here, that means sine θ1 is the same sine θ2. So that means the angles have to be the same, right? Very simple to figure out mathematically, but even simpler, just remember reflection, same angle, okay? So I actually want you guys to try this question, going over a lot of the stuff we just mentioned. Okay. I'm gonna end the polling. So 80% picked A, right? Which is the correct answer. The angle of reflection is 60 degrees, which I'm very happy about. Like I mentioned, the angle of incidence you have to know is the angle that it comes in at, right? For reflection, the angle it comes in at is the angle it comes out at. So 60 comes in, 60 comes out. That's it. Angle of refraction is 60 is not true, because so refraction follows the n1 sine θ1 equals n2 sine θ2 rule, right? So the only way for the refracted angle to be 60 degrees would be if the two surfaces, air and water, had the same n value, but they don't. The index refraction of air is 1, water is 1.33. So it would actually, the angle would decrease, right? I don't know what it would be. It would be like 50 maybe, but it would be less than 60, right? Total internal reflection would occur. Again, this is not true, because total internal reflection only really happens when you go from a higher index substance to a lower index substance. So if we were going from, say, water to air, that may happen, even though it likely wouldn't, because 60 degrees is too small of a number. But it may happen if we were 80 degrees, if we're going from water to air. From air to water, the angle would actually decrease, right? Wouldn't be above 90, it would actually be below whatever it started out. So it'd be below 60 or below 80 or whatever we started off at, right? So that's why C can't be true and D is, yeah, because C is not true, D is not true.